You're not going to miss this episode of the AI Show. We talk all about AI evolution explained, GPT-5 versus 4.1 versus O3, smarter choices. For Smarter Business, my friend Alex, make sure you tune in. Hello, and welcome to this episode of the AI Show. We're talking all about GPT-5 versus GPT-4.1 versus O3. How do you make the right choices? With my friend Alex. How you doing, bud?
Hey, Seth. Great to be here. I'm doing pretty good. How are you doing?
Fantastic. So tell us who you are and what you do.
Awesome. Yeah. So my name's Alex. I'm a product manager on the Azure AI Foundry models team. And so what I do is I help bring the newest, latest, and greatest models from our amazing set of model providers, companies like OpenAI, xAI, Meta, and we bring those to Foundry so that our customers can use them in their agents and building their applications.
So this is all awesome, but I feel like once you have a lot of choices, it's hard to make a decision. So I'm hoping you can sort of help us out with that. How do you know when to use what? Can you give us a little primer?
Absolutely. So choosing the right model is a big challenge. So there's so many different models. We're bringing new models, and our providers are creating new models all the time and releasing them. So picking the right model, you really have to understand what your use case is, and then have a clear understanding of what the model's trade-offs are. So what their pros are, what their trade-offs might be. So which models are more expensive than others, what models are more performant in different categories like reasoning than others, and that'll help you pick the right one. And I'm happy to help with that with GPT-5 and some of the other models we have.
All right, let's start with GPT-5. How do you explain this one?
Yeah, so GPT-5 is the latest sort of model family from OpenAI. So when we say GPT-5, we're not just referring to a single model, we're referring to a family of models. And in this case, GPT-5 contains both reasoning models like GPT-5, GPT-5 Mini, and Nano, and then also a chat model. So picking GPT-5 for your use case really depends on what specifically you're looking to do. But since we're bringing reasoning and conversation into one family, you can really do anything with GPT-5, anything you can think of within your organization. What GPT-5 really excels at is code generation. And then you also have a ton of flexibility with things like tool calling. And I'm going to talk more about that today. So that's really what GPT-5 is great at.
So it's more of like a collection of models. GPT-5 is a sort of a family of models, which is something that I didn't realize beforehand. Is that a good assessment?
Yeah, exactly, Seth. So it's a family of models, a collection of 4 models to be specific.
All right, so let's go to the next slide. Tell us about each one of those.
Yeah, so we have 3 reasoning models. And as we've seen with other models in the that have been released by OpenAI, they sort of use this naming convention of mini and nano for smaller and faster models that are also reasoning models. So we've sort of shifted over from the O-star framework to, in this case, just GPT-5. So we have GPT-5, which is the mainline reasoning model. It's going to be best suited for those highly complex queries that require deeper sort of chain of thought reasoning. It's really good for things like analytics and complex decision making. GPT-5 Mini is a little bit smaller than GPT-5, lower latency, but still great for reasoning. And then Nano is the smallest, fastest reasoning model. And then, of course, we have Chat, which is best optimized for things like multi-turn chat scenarios.
So here's a question, because we had Jennifer Marsman talk about GPT-5, but maybe I didn't understand it correctly. Is the GPT-5 like the one all the way at the top? Does that one like decide to do like model routing to different models, or am I mistaken here?
Yeah, so great question, Seth. So GPT-5 is this collection of models. Within the OpenAI API directly, they use a routing service that essentially will pick the best model based on the query. We also have on Azure AI Foundry, we have a model router, and our model router is really great at helping you pick the best model based on the input. It does it seamlessly, it does it for you. So you input your query, your prompt, and then the model router will route it to the best model based on the prompt.
Awesome. All right, so let's take a look at this here, because there's a lot of stuff to think about when we start to compare these models, correct? So it's good to get the framework of the 4 models, well, family of models, 4 things. But can you explain those, like the difference here? Because there's a lot to think about.
Yeah. So GPT-5 is the latest set of models from latest set of reasoning models from OpenAI. So we've had other models in the past that have excelled in different categories. We know that O3 was really good at like math heavy tasks, for example, but O3 is being phased out now in favor of GPT-5, since GPT-5 in terms of the performance benchmarks, as you can see, does perform better in those categories. So we're seeing GPT-5, in particular, the mainline reasoning model is outperforming O3 in those areas where O3 was the strongest. We also see with GPT-5, we have a larger context window. We have 400,000 input tokens compared to O3 with 200,000 input tokens. So GPT-5 not only supports more input tokens, it's also going to perform better across those benchmarks. We do see that its output cost is slightly more expensive, only by $2 for the output, but the input is considerably less expensive there too. So GPT-5 is really the kind of evolution of O3. I just want to kind of emphasize that point. We're kind of, from a reasoning model standpoint, GPT-5 is the next evolution there. And then compared to 4.1, GPT-5 chat is sort of what the next step there would be. But I want to emphasize that GPT-4.1 still excels in some certain categories, in particular categories that require a large input context. So large document analysis, things like that.
I see. So O3 is like you can still use that one, but that one's gonna it's gonna be deprecated in favor of 5 because 5 does the things that O3 does, but better. But then if you have a need for a larger context window, are concerned with cost, but it's not really off that by that much, you would go with GPT-4.1. Is that what I'm understanding?
Exactly. Yeah. So GPT-5 chat does a really good job at handling those low latency real-time chat scenarios that 4.1 is also really good at. But 4.1 does have a bigger context window.
Got
So
it.
if you need a ton of context, 4.1 is great for that.
Yeah, and to me that's kind of a different task, right? Because it
Mhm.
feels like that would be more of like a process automation where you're looking at very large things.
Yeah.
Someone's not going to chat a million tokens in the context window, is my guess. But that's I don't know. Maybe there is someone who can do that.
No, you're right. It's probably an unlikely thing. Yeah.
All right, so let's take a look at the next slide here. Let's tell us about what makes GPT-5 a little bit different.
Exactly. Yeah. So we took a little look at the benchmarks there and some of the improvements, but in terms of functionality, GPT-5 supports some new things that are pretty cool. So the first is free form tool calling. So in the past with tool calling, we would need to specify those tools using structured JSON. With GPT-5, you can basically just send the raw text payloads. So if you have some Python code, if you have a SQL query, you can just send that directly to the tool, and the tool will be able to handle that with GPT-5 without actually needing to sort of structurally define that tool with JSON. And this is really, really great for making your applications more developer-centric. Getting started with tools is a lot more seamless. GPT-5 also supports parallel tool calling. So this allows it to call multiple tools essentially in parallel in a single model turn. So it makes using the model faster, and in turn, it makes your agents run faster. So a user doesn't have to wait for one tool call to happen, then another, then another. If they're not dependent on each other, then they can all just happen at the same time. So this makes your agents run a lot faster.
So help me understand this from a mechanical perspective, how it works. So effectively,
Mhm.
you put something in the chat. If you get the raw response, it'll tell you to call 3 function calls, for example, and then you
Yeah.
can run those at the same time, and then put them back on the response back on the thread at the same time. Is that what that means?
Yes, essentially, yeah. So what we're doing is we define our functions within our application, and I'm going to show you how to do this in just a minute here. So you
Cool.
define your functions, what your tools, what you want them to do, maybe calling some sort of weather API or some time or whatever the tool might do. And within your application, maybe you're prompting your model to do something. And if the model determines it has to use multiple tools to accomplish what you're asking it to do, what it's going to do is call those tools in parallel. So it's going to use different threads to call them at the same time, and then it's going to get those responses back and then integrate them before it returns the final response to the user.
I see. So that's a function of the actual GPT-5 service that's doing that
Mhm.
on your actual behalf. Because I mean, most people maybe they don't know this, but the LLM itself doesn't call functions. It's a service that calls a function. It's the LLM that recommends the functions to call. The service just makes it much easier to call multiple of them at the same time. Am I getting this right?
Yeah, that's exactly right.
All right. So let's take a look at some of the parameters. So effectively, to make this actually work, you gotta set parallel tool calls to true. One of the things that I did not get the understanding of the trade-off or the difference. What's the difference between reasoning effort and verbosity? Because help me understand the difference.
Yeah. So reasoning effort, there's 4 values for it. And there's one new value for GPT-5 called minimal, which is the lowest possible level of reasoning. And then we have low, medium, and high, which are the same values for previous models. Essentially, what this reasoning effort parameter controls is how deeply the model is going to think before calling various tools or answering the prompt from the user. So if you want the model to think a lot, you can set reasoning effort to high. This is going to make latency longer because the model is going to take more time to think, and it's going to allow it to create sort of more deeper analysis, think deeper before doing those various actions. If you set it to minimal, it's going to think in the lowest possible amount while still being a reasoning model and still sort of doing that chain of thought thinking. Verbosity, on the other hand, isn't actually controlling how deeply the model is thinking. It's simply adjusting the level of detail the model is providing in its response. So if the model is more verbose, it's going to give more detail with its responses, and if it's less verbose, it's going to give less detail with its responses.
This is really handy because I've had models kind of like say a lot of stuff, and it's like, whoa, I wish I could control that, and this is a control of that sort of thing.
Exactly. Yeah.
All right.
So you can have a model that's super, super thoughtful, but maybe you don't want it to kind of give you paragraph long responses. So
I love it. And so here's the diagram that I should have pulled up when we were asking about function calls. What are we looking at here?
Yeah, so here we've got just a sort of an example diagram of what parallel function calls essentially what it essentially is. So before parallel function calling, we would do sequential tool calls. So up at the top, we can see on the various model turns, we're calling some various function, in this case, read file, with 3 various files, and then we're getting those responses. With parallel tool calls, it's just one model turn, and then we're actually doing all 3 of those reads at the same time, and then getting that response. So it's all happening at the same time instead of 3 separate model turns. And what this enables is essentially just faster agents, faster thinking, and then a better sort of interaction with users.
So this is awesome. Is there any way to show us what this looks like in code?
Yeah, absolutely. So what you see here, Seth, is 2 files that I've created, 2 Python scripts. And what I'm going to be showing you here is some regular function calling, which I'm sure you're very familiar with. And then I'm also going to show you parallel function calling. So how can we parallelize these function calls when we have multiple function calls to make? So first, with regular function calling, here what I've done is initialize my Azure OpenAI Service client, define my deployment, and what I've got is some time zone data. So we have some various cities around the world, Tokyo, San Francisco, Paris, and I have the associated time zone for those cities. And then I've defined a function here called getCurrentTime. And this function takes in a location, a city, and it's going to return the current time at that location. So I'm using a function of datetime here to do that. So that's what this function here is doing. And then what I'm doing here is I'm defining that tool to use with my model. So I'm actually using GPT-5 Nano in this case. And GPT-5 Nano, as Seth and I talked about, is like a great model for low latency scenarios. So that's really good for building applications that need some reasoning, but need to do it really fast. Nano's really good at that.
That's cool.
Yeah. So I've defined the tool here. In this case, I'm defining the getCurrentTime tool. So I'm describing it as sort of getting the current time in a given location. I've defined the properties, and then what's required here, which is just the location. So what I'm essentially prompting the GPT-5 Nano model here with is, what's the current time in San Francisco? So I'm asking GPT-5 to call the tool and then give me the current time in San Francisco. So down here, I'm sort of defining what the API call looks like, processing the model response, and then here's where I'm actually handling that particular function call. So pretty standard use case for a tool. And if I run this function, I run this file, we can see that we're going to get a response with what the current time is in San Francisco. So we see that it's 11:56 a.m. in San Francisco right now.
Yeah, and could you scroll up, because I want people to see this. This part is the part that's like kind of the magical bit. Here, when you get the response on line 83, if it's asking for a tool call, you look for the name and then you execute the actual function with the arguments, and then you append the response of the actual function call to the thread. Is that right?
That's exactly right. Yes.
Perfect. And then you get a good response. Okay, cool. That was really fast too.
Yeah, exactly. So GPT-5 Nano is super quick, super low latency, but it can still do really strong reasoning. So it's not as strong in terms of its reasoning capabilities as the mainline GPT-5 or GPT-5 Mini, but it's still very strong. So it's really good at those scenarios where you need something that's quick, but also thoughtful.
Got it. All right, so let's take a look at GPT-5 parallel tool calling to see the difference.
Yeah. So let's dive into this one here a little bit. So we're setting things up the same way, using the same model, GPT-5 Nano. But in this case, we've got a little bit more data to work with. So instead of just time zone data, which we still have here, we've got some new data for the weather in these various cities as well. So we have the temperature and then the unit of temperature in these cities.
Got it.
So I've got the same function here. Right here, get current time. This is doing exactly the same thing that I was doing here in function calling. But I've got this new function as well called get current weather. And this one's going to take in the location and the unit. Oh, let's not do that. And then it's actually going to return the current weather in that location. So we have the data. And then here's a function that can basically check what the weather's like in that location. So I'm going to run I'm going to define the tools the same way I did before. Get current time is defined the same way. And then here, get current weather is defined as well. I'm requiring the location as input. And then sort of what this function is doing is it's getting the current weather in that location.
Mm-hmm.
And then I am prompting the model with what's the weather and current time in San Francisco, in Tokyo, and in Paris. And one thing I'd love to just call out here as well is here I'm defining tools using JSON. With GPT-5, you don't have to do this. So you can just call the function directly with Python or with SQL, for example.
What does that look like?
Yeah, so essentially, if you have a like a Python script that does something, or let's say you have an SQL query. You have an SQL query that calls like a database, and it's getting, let's say in this case, it's getting like employee data, for example. So what you could do is with that SQL query, you could just have it defined in plain text. So it's just a raw text like string, SQL query
as
string.
part of the prompt.
Exactly, as part of the prompt.
Makes sense.
Yeah, and then you have that string defined, you know what it's going to do, and then you basically can have the model use that string and call a tool directly with it. So you don't actually need to, in those cases, define the tool with structured JSON. You can just have the raw text SQL query payload, and you can just send that as the prompt to the model, and then the various tools will get called with that raw text payload.
I love it. All right, let's take a look at how we parallel call these things.
Yes, absolutely. So if we scroll down a bit here, we've defined those tools. Here's our first API call. Here we're asking the model to use the functions. And then here's where we're actually processing those responses. So as you can see, Seth, it's really the same handling as we saw before with function calling. So in the response, we're essentially just going through and seeing is the tool in the set of tools that we have? And then if so, we call it, and then we append those results to the message that the model is going to return to the user.
Got it. Got it. And now is this, so here's it. I see. So in the for loop, in this, it might be returning more than one of these function calls, and you're just executing it and put them on the thread as they come in.
That's right.
Okay, cool.
Yeah.
Cool. All right, let's see what it looks like when we run it.
Yeah, so let's go ahead and run this one here. Yeah, so first we see really fast response there. And then what we're seeing is all of the function calls that were made. So we have this all printed out here. So we can see get current weather is called with San Francisco. And then we see get current time is called for San Francisco. And then we see that it happens for Tokyo, the two functions, and then it happens with Paris with the two functions. So essentially, GPT-5 is calling all of those tools for all three of the cities, and it's doing this in parallel. So it's not just calling one, then another, then another. It's actually doing it all at the same time. And then it's printing those results, and we can see we have, we're printing those results, and we can see for the three cities, we have the weather and the time for all three.
Well, this is awesome. Where can people go to find out more about this? I have a couple of links. Tell us about this one.
Yeah, so
the blog post. Tell us about the blog post. Sorry, you're probably not seeing it. I'm pointing at something you're not looking at. So this is a blog post. Tell us what's there.
Yeah, so highly recommend you check out this blog. We highlight what's new with GPT-5, its advantages, the new features we're enabling on Foundry with it. So highly recommend you check that out.
Awesome. And then on Learn, there's some information similar to what you just showed. Is that correct?
Yeah, we show all of our OpenAI models, the reasoning models, what you can do with them, and then, of course, examples of how you can use them.
Well, this has been amazing. Thank you so much for your time, Alex.
Thanks so much, Seth. I appreciate it.
And thank you so much for watching me learn all about AI Evolution Explained, GPT-5 versus 4.1 versus 03. Smarter choices for smarter business, my friend Alex. Thank you so much for watching, and hopefully we'll see you next time. Take care.